Welcome back. It's time to learn another data structure. This is a big one, and an exciting one at that, because it's going to introduce a lot of new topics, especially when we get into algorithms as well. They're called trees. And no, not these kind of trees, more like this. Trees are a data structure that have what we call a hierarchical structure. As opposed to something like linked lists or arrays, which are linear, trees can have 0 or more child nodes. You see, a tree usually starts with a single root node or a parent node, and every child of the tree descends from this root node. So it's kind of like an inversed tree, really. And every child of a node descends from only one parent. So you have a parent-child relationship that you see is unidirectional, that is, it's going one way. And you also have leaf nodes, which are the very end of a tree data structure. Finally, within a tree, you can have things like subtrees, such as the area over here circled in red. 3, 6, 7 form a subtree. And tree data structures are very important because you work with them every day. If we go to twitter.com or any website for that matter, and we open the developer tools, just like I did here, if I go to the Elements tab, you see our web pages are created by something called the DOM, or the Document Object Model. And this is a tree data structure. It doesn't look like a tree that I just showed you, but the browser is just making it look nice. But underneath it, we have head and body that are children of the HTML tag. Inside the body, we have all these children. And inside these children, we have more children, and they're all connected hierarchically to one another. I'm sure everybody has tried to play chess online versus a computer. Well, a computer in a chess game, at least back in the day before we had things like machine learning, used a tree data structure to make a decision. Should I make this move? Or should I make that move? Or should I make that move? And it would pick moves based on which move had the better outcome. Facebook comments, for example, are a tree data structure where I can comment on a friend's photo and that friend can comment on my comment. Family trees can be represented in a tree data structure. And for us engineers and programmers, you might have heard of the abstract syntax tree. If I Google abstract syntax tree here, well, this is how programs or code is usually being run. Usually we write code and then it gets broken down by the machine into this abstract syntax tree so that it understands what we wrote down. And this, as you can see, uses a tree data structure. The beauty of trees is that we use the same principle as we did in linked lists. That is, we have nodes. And these nodes can contain any type of information that we want. We can have user information, we can just have numbers like we have here. Anything we want, we can contain within a node. Now you might be thinking, this kind of reminds me of a linked list. And you'd be right. Linked list is technically a type of tree, but with just one single path. And it's linear. There's only one way to go from top to bottom versus what we've seen before in a normal tree, like this one. Now, a thing to keep in mind here that might be different than a linked list is that a node can only point to a child. As you can see, all the arrows point down. There's always one entry point, which is the root, but nodes don't really have to reference their parent. Now, just like in real life, there are many types of tree data structures that we can have. And if you go to Wikipedia and you look for all the tree data structures, it's going to, well, intimidate you, that's for sure. Because look how many different types of trees we have. Just like in real life, how we have all these different types of trees, there's different types of trees that we can have for a specific use case. But don't get overwhelmed. In this course, we're going to go over the main ones that get used, I would say, 90% of the time. And the ones that you're most likely going to encounter during an interview. Because at the end of the day, once you understand what a tree data structure is like, how to create it, how to perhaps use some actions on it, then all the other trees that you saw are just minor alterations to what we know. Now, I want to warn you. Back in the day when I took a class on data structures, this part, especially trees, really dragged on. and made me not interested in data structures because there's so many things you can talk about when it comes to trees. I'm going to try and keep you engaged to the best of my ability and try and be efficient through this section and show you the important aspects that you need to know for an interview and to lay the foundation, not to teach you every single tree that there is, which is not going to benefit you. With that in mind, I'll see you in the next video. Bye-bye.